My name's Pete Green. I'm a senior lecturer at the University of Liverpool. This project is about float glass, so that's glass that sits on a bed of molten tin, as it cools. It's with NSG Pilkington, and we want to develop a model which, from properties of the furnace, so temperatures, etc., is able to predict product quality. Ultimately, we want to use that model to improve product quality, reduce costs, reduce carbon emissions, and that kind of thing.
What is the vision for this project?
So the vision for this project is basically a model that works. And by that, I mean, it doesn't only have to predict product quality reliably, it also needs to do so with confidence bounds, which are useful if the model is going to influence high consequence decisions. But it also needs to fail gracefully. So by that, I mean, if the model is applied far from its training data, we need to make sure that it's not overconfident, because that will harm the trust that people place in it. Ultimately, if the model is successful, then we want to deploy it over float glass lines all over the world, basically.
What have been the biggest challenges so far?
So one of the biggest challenges we've had is that the pre-processing of the data before it gets to the model can only be done successfully using glass maker knowledge, basically. It can't be addressed using only data science, for example. So while we from Liverpool are there trying to transfer knowledge about AI models, at the same time, we're trying to learn about how glass is made. So the knowledge transfer is two ways. It's challenging because we're out of our comfort zone, but of course that's what makes it interesting as well, and it's a good chance to learn.
How are you already making a difference to the transformation of foundation industries?
So the model has now been deployed at the UK5 line. So as we speak, it's making predictions every 20 minutes. It's currently under a validation period. We've also wrapped an optimizer around the model. So as well as predicting what's going to happen in the future, it's also suggesting moves to the furnace operation that could be undertaken to, for example, reduce carbon emissions without harming product quality. So the next step for us really is for the model to start to influence some of the furnace management decisions that are taken.